Hey everyone, and welcome. If you're tuning in, it means you're ready to master the fundamentals of literally one of the most transformative technologies of our time. In this explainer, we're going to embark on a massive journey, starting from the macro world of drones, zooming all the way down into their micromechanics, and then pulling back to see how they fit into the broader rules of the sky. I am absolutely thrilled to guide you through this, so we can crystallize exactly what you need to know to take flight with total confidence. All right, let's kick things off by getting on the exact same page. What are we actually talking about when we say drone? Technically, it's an unmanned aerial vehicle, or UAV. Basically, this just means it's an aircraft that doesn't have a human pilot physically sitting inside it. Instead, you're controlling it remotely from the ground with a transmitter. Or in some of the really advanced setups, the machine is flying completely autonomously, following pre-programmed routes using some incredibly smart onboard software. So here's our flight path for today's explainer. We're going to cover Welcome to the Drone Age, drones of all shapes, anatomy of a drone, rules of the sky, and finally, etiquette and safety. Let's get right into it. Okay, Section 1, Welcome to the Drone Age. Let's take a look at the sheer scale of the UAV revolution happening right above us. UAVs have totally escaped the realm of sci-fi, you guys. They are actively reshaping our modern world right now. We're not just talking about cool tech toys here. These are essential tools across massive industries. Think about it, capturing breathtaking cinematic aerial photography that literally used to require renting a helicopter, or running complex agricultural analysis to boost crop yields, surveying huge infrastructure networks, dropping off critical medical supplies, and even performing life-saving disaster management and search and rescue missions where it's just too dangerous to send a human. Moving right along to Section 2, drones of all shapes. Let's see how this incredible variety breaks down. There's a really vivid contrast in the drone world. On the super light end, you've got nano drones. These weigh less than 250 grams, fit right in the palm of your hand, and usually max out at about 5 to 10 minutes of indoor flight time. But as you scale up through mini, micro, and small drones, which are kind of your standard hobbyist and professional models that fly for maybe half an hour, you eventually hit the big leagues, the medium to large class. These beasts weigh over 5 kilograms, carry heavy payloads like LiDAR scanners or massive camera rigs, and are engineered to stay airborne for well over an hour. But it's not just about physical size, right? We also categorize these machines by their mission, because what you want to do with it completely dictates the tech and the rules you have to follow. Recreational drones, those are your affordable, fun entry points for casual weekend flying. Commercial drones, though, are built to make money, like real estate photography or package delivery, and they require strict regulatory compliance. And then, of course, you have military drones, which are heavily encrypted, highly advanced systems used for surveillance and combat. So a huge part of this is just choosing the right tool for the job. You've got to balance the simplicity of 4 rotors against the heavy-duty redundancy of 8. A quadcopter is definitely the most common. It's simple, highly stable, and great for standard photos. But an octocopter? With its 8 rotors, it offers maximum stability and, crucially, redundant safety. If one motor suddenly burns out mid-flight, the other 7 actually compensate. It's an absolute lifesaver when you're flying tens of thousands of dollars of cinematic gear. Okay, Section 3, Anatomy of a Drone. We know what they look like from the outside, but what actually makes them fly? If you peel back the plastic casing, a drone is almost like a living creature. First, you have the frame. That's the skeleton. It's usually carbon fiber or hardened plastic to be as light and rigid as possible, so it can support everything. Then you have the propellers, which act like the wings, pushing air downward to generate lift and defy gravity. And finally, the motors are the muscles. These brushless powerhouses spin the propellers with immense torque to give the drone its crazy maneuverability. Now, let's trace the flow of energy. How does the brain talk to those muscles? Step 1. Your LiPo, or lithium polymer battery, provides all that lightweight, raw electrical juice. Step 2. The flight controller, the literal brain of the operation, takes in your commands from the transmitter. Step 3. That brain rapidly talks to the ESCs, the electronic speed controllers. The ESCs are constantly telling each individual motor exactly how much power it needs, hundreds of times a second, to execute your move flawlessly. But honestly, muscles and a brain aren't quite enough. A drone needs senses to balance in the air, especially in a gust of wind. A GPS module gives it exact spatial awareness and enables that awesome auto-return to home feature. Internal sensors, like gyroscopes, keep it perfectly level, while barometers lock in its exact altitude. Toss in a camera mounted on a gimbal,
which is a pivoting mount that keeps the lens perfectly steady even when the drone tilts, and you've officially given your drone vision.
All right, Section 4, Rules of the Sky. We've zoomed in on the mechanics. Now let's zoom back out to see how we safely integrate these things into the real world. 400 feet. Burn this number into your memory, because this is your hard ceiling. You are generally never allowed to fly higher than 400 feet above the ground. And this vital rule exists for a very good reason: to keep your drone safely away from manned aircraft, like commercial planes or medical helicopters that typically operate right above that altitude.
Now, you might be wondering, can I just buy a drone and fly it anywhere? It's a tempting thought, right? You unbox it, charge it up, and just want to launch it from your backyard or a local park. But let's burst that bubble real quick. The sky is definitely not a free-for-all, and the answer to this is a resounding no. Violating restricted zones carries some really severe legal and safety consequences. You literally cannot fly near airports. Even a tiny drone getting sucked into a jet engine is catastrophic. Military bases and government installations, absolute no-fly zones for obvious national security reasons. And even national parks are heavily protected to prevent stressing out the wildlife and to keep noise pollution down. You can't fly there without very specific prior authorization. And if you're stepping up to commercial work or flying heavier gear, it gets even stricter. Authorities like the CAA, the Civil Aviation Authority of the Philippines, require you to officially register your drone if it weighs more than 7 kilos, or, and this is key, if you're using it to make any money at all. Commercial pilots have to pass rigorous exams to get certified, and you'll need special permits to fly over sensitive public areas, like stadiums, schools, or busy plazas.
Which brings us to our final section, number 5, etiquette and safety. This is all about your personal responsibility as a pilot. You really need to treat every single flight like a professional aviation event. Follow a strict pre-flight checklist. First, physically inspect your drone for micro cracks in the props or loose frame parts. Second, monitor the weather. Wind and rain will absolutely wreck exposed electronics. And third, always maintain VLS, or visual line of sight. You have to be able to see your drone with your own 2 eyes at all times so you don't crash into unseen obstacles. Being a good pilot is also about respecting people on the ground. A modern drone with a high-def zoom lens can easily peer into private property. So actively avoid flying near residential windows or private backyard gatherings. Respecting privacy is absolutely crucial. It's exactly how we, as a community of pilots, build public trust instead of fear. And please, never make your hobby a hazard to others. Flying over a crowd is incredibly dangerous. If one motor fails, that drone is basically a falling brick. Also, stay far away from public events or emergencies. An unauthorized drone hovering around a fire or natural disaster can literally force life-saving rescue helicopters to ground themselves because of the collision risk. Always stay out of the way of first responders. Let's apply all this to a real-world scenario. Imagine a farmer needs a drone to monitor crops across a massive property. Based on what we've learned, what do they need? Well, they'd probably want a smaller medium-class drone, maybe a hexacopter so it can handle the harsh winds out in the open fields. It needs a high-capacity battery for long flights and a specialized multispectral camera. And because it's for an agricultural business, it falls strictly under commercial regulations. So CAA registration and official pilot certification are an absolute must. We have covered a ton today, from the macro impact of the UAV revolution down to the carbon fiber frame in ESCs and all the rigid rules that govern our skies. With the core mechanics clear and the rules of the sky understood, the only question I have left for you is this. When you finally throttle up and take to the air, how are you going to use this incredible technology to change your perspective on the world?